let's consider method 2 of solving the same question, alright. So the question is count set bits in an integer. So the problem statement is to count the number of bits, number of ones in the binary representation of the integer. So suppose that you have 6, okay. How can you represent 6 basically? It is going to be 8, 4, 2 and 1. Alright, so 6 is 4, 5, 6. So it is 2. You have 2 ones here, so therefore the output is 2. So similarly for 13, if I take it 8, 4, 2, 1, 8, 9, 11, 12, 13, right? So I can see that I have 1, 2 and 3 ones here. Set bit is basically what? Set bit is the number of ones that is present. Alright, that is what you call as set bit. So here you have 3 ones and therefore the output is 3. Alright, makes sense? So we considered a previous method, alright. What did we do? We found out the last most bit using the AND operator, and every other time until the entire number amounts to 0, what did we do? We use the right shift operator. Fine. So right now let's use the Brian's algorithm, okay? So let's basically understand what the algorithm is all about and then proceed with it. So initially, let's suppose there is a number n, okay? And let me consider it to be as 5, let it be 15, okay? What is n minus 1? It is going to be 14, okay? So how do I represent 15? 8, 4, 2, 1, 8, 9, 10, 14, 15. Alright, how do I represent n minus 1? 8, 9, 10, 11, 12, 13, 14 and 0. Alright, let's consider another thing. Let n be equal to 8, okay? So what is n minus 1? 7. So if n is 8, what will happen? 8, 4, 2, 1, 8. 7 is going to be 0, 1, 1. Alright, let's consider another number as well. Let n be 16 and n minus 1 is going to be 15, okay? So 16, what will happen? You will have to add another bit here. So 16, this is 16, okay? So for 15 is going to be 0, 1, 1, 1 and 1. Alright, so do you notice something, some pattern between n and n minus 1? If so, what is the pattern? You can actually see. So there is some n and you are subtracting 1. So what is the pattern that you can notice is that, you know what? The rightmost set bit, okay, is getting swapped. The rightmost set bit is getting swapped with the other one. The rightmost set bit is swapped and all the others remain the same. Okay, fine. Similarly here, the rightmost set bit, what is the rightmost set bit? This is my rightmost set bit, that is getting swapped, and every other bits after the rightmost set bit will also be swapped. Okay, so the rightmost set bit is swapped along with every other bit in the towards its right. Alright, so similarly here, what is the rightmost set bit? 1 here, so it gets swapped. Fine, the rightmost set bit is swapped along with every other element towards its right. Okay, so rather than this, let's consider like n be 9 and n minus 1 be 8, okay? So it's 9, 8, 4, 2, 1, what happens? 8, 9, 0, 0, what is 8? So what do you see? The rightmost set bit is only swapped, alright? Or let this be, n be 7 and n minus 1 be 6. So 4, 5, 6, 7. So what is 6? 0, 1, 1, 0. So what is again happening? The rightmost bit is changing. So if n is 6, n minus 1 is 5. So 0, 1, 1, 0. What is 5? 0, 1, 0, 1. So what is happening? This is going to be our rightmost set bit. Rightmost set bit is swapped along with every other element, every other bit towards right is also swapped. Whereas this remains the same. Alright. So this is the pattern that is followed between n and n minus 1 basically. So for n and n minus 1, what is happening? The rightmost set bit is altered along with every other bit towards its right. Alright, makes sense? Whereas all the other bits towards the left shall remain the same. Okay, so this is a pattern that n and n minus 1 will actually follow. So suppose if I do n and n minus 1, alright, so we understood the pattern. Alright, so n and n minus 1, what is happening? The rightmost set bit is swapped along with every other bit towards its right. Okay. Now, what happens if I do n and n minus 1? Can you guess? If I do n and n minus 1, the rightmost set bit will get unset. That is, so just notice here now. I'm telling you that 1111 and 1110 is using the AND operator. What happened then? This will get 0. So the rightmost bit will get unset. Unset is nothing but set is 1. Okay, unset is 0. Unset is 0. Alright. So it will get converted to zeros what I need. Alright. So the aim of the entire thing, so right now I got this. Okay, so suppose if n is 15, then n minus 1 is 14, and I'm using the AND operator, what is happening? I am unsetting the bit, unsetting the rightmost set bit. Fine. Now, let's consider, let n be, fine. Now, let n be 1, 0, 1, 0. So what is it basically? N is 10. Then we consider n minus 1, that is 9. So 8. So what will happen? So what do you notice? Again, the rightmost set bit is changed along with every other bit towards its right. Alright. So now I am using the AND operation. So what should happen? The rightmost set bit must become unset. So rightmost set bit must become unset. You have to get this. Alright. Fine. And then, what is this now? This is basically 8. Alright. So, what I am doing? I am unsetting the rightmost one. Alright. Again, if I do n minus 1, this is going to be 7. So, 4, 5, 6, 7. Alright. Now, if I do the AND operation, what happened? The rightmost set bit will become unset and others will be the same. Can you visualize it? The rightmost set bit will become unset and all the others are going to remain the same. Alright. So now it is 0. Fine. So how many times are until it reaches 0? How many times did I unset things? I did it once, twice. Okay. When my value of n is 10. Alright, how many ones does 10 have? 2. How many times did you unset the rightmost one? You did it 2 times. It's obvious, right? How many times am I unsetting the rightmost one that is present? There are only 2 ones present. So you have to unset it twice. Alright, which is basically the logic of the program. To count the number of ones in the binary representation of the integer. So every time I unset the rightmost one, I can increment the counter, right? So this is the concept which we shall be following right now. Alright. So when should I start? Okay, I am trying to unset the bit. Fine. And the logic is n and n minus 1. So when I do n and n minus 1, I am unsetting the rightmost bit. So I'll have to increment my counter. I am unsetting the rightmost bit and this. And then secondly, this is considered as a value of n again. So n is equal to n and n minus 1. So initially I will be getting a value of n. I am doing n minus 1. Then I will have to increment the counter. First thing. Secondly, I will have to use the value that I get after that as a second value of n. Okay. Fine. Makes sense. So right now, when did I stop? I have stopped when the value of n is 0. So 0, I can't do n minus 1 is minus 1 or not, right? I have stopped when n is 0. So while n is greater than 0, just run this. Okay? So this is basically the point. So that's it. This is the program. Oops. So while n is greater than 0, n is equal to n and n minus 1. So every time this happens and n is having a value, you increment the counter. And then for this derived value of n, what am I supposed to do? I am later supposed to do it again until n is not equal to 0. Fine. So this is basically how it is going to work. This is the first statement, second and third, and lastly I'll have to return what? C. Here C is equal to 0. Fine.